guys, so welcome to the very last lesson of Unit 9, which is called Theoretical Yield and Percent Yield. And so this lesson is kind of more lab-based. And so the premise behind this is that when you actually go into a lab and run a chemical reaction, sometimes you don't get the amount of product that you predicted or that you calculated should come out of the reaction. And there can be kind of various reasons for this. Maybe you spill something, during the reaction. Maybe the reaction doesn't go all the way to completion like it should have. Maybe when you're transferring the product to a different container, you lose some of it or some of it remains behind in the other beaker. Or sometimes reactions can actually form other products that you weren't necessarily expecting. And so this brings us to kind of the difference between two important terms, and that is theoretical yield and actual yield. So the theoretical yield is the amount of product that you predict solely based off of your starting amount of limiting reactant. And so this is kind of like your pen and paper calculation. If everything was perfect, how much product should you get from your limiting reactant? Okay, so in theory, the amount of product you should get comes from those pen and paper calculations from the limiting reactant. But the actual yield is kind of what actually happens, when you go into the lab. And so it's what you make at the end of the day once you've performed the experiment. And like we said, there are a few reasons why this can differ from the theoretical yield. So we've already mentioned kind of losing product, spills, the reaction doesn't go all the way to completion, you form different, byproducts that you weren't expecting. And so what we're going to start out by practicing is how to calculate, before the reaction, what the theoretical yield should be. And then we'll talk about how to compare the theoretical yield and the actual yield to see how well you did, when you were doing the experiment in the lab. All right, so how to determine the theoretical yield? So step 1, determine the limiting reactant. Then step 2, use the limiting reactant to calculate the amount of product that should theoretically be formed. And again, the reason we have to determine the limiting reactant is it's going to limit the amount of product that we can make. All right, so we've got our equation here, and they give us our two reactants. We have 5 moles of carbon monoxide reacting with 7.5 moles of hydrogen. And so first step, we need to figure out which one of these is going to limit the amount of product that we form. So just like before, we're going to first find the limiting reactant by answering the question, which reactant gets me the least moles of product? So here I only have one product, so that kind of makes it easy. I'll be comparing both reactants to CH3OH, that's methanol. Okay, so again, I was already in moles, so I'm ready immediately to go to the mole ratio. So for every 1 mole of methanol, I need 1 mole of carbon monoxide and 2 moles of hydrogen. And again, those mole number ratios come from the coefficients of your balanced chemical equations. I go ahead and plug that into my calculator. The first one, 5 times 1 divided by 1, will just be 5 moles of my product. And then for the second one, 7.5 times 1 divided by 2 will get me 3.8 moles of CH3OH. All right. So now let's ask the question, which one has limited my amount of product? In this case, the reactant hydrogen produced less product. It would be the limiting reactant, which would make carbon monoxide rather, the excess reactant. Okay, so now what I'm ready to do is kind of continue on with that limiting reactant to find the amount of methanol in grams. So I know based off the limiting reactant, I should have made 3.8 moles of CH3OH. So what I can do is just continue that calculation and go from moles of CH3OH to grams of CH3OH. Anytime I'm going to grams, this requires the molar mass from the periodic table. So I would add up 1 carbon, 3 hydrogens, 1 oxygen, and 1 additional hydrogen to get 32.05 grams, and that's again per 1 mole. All right, so then I would go ahead and plug that into my calculator, 3.8 times 32.05 divided by 1, and that gets me as an answer 121.79. I go back to my very start of the problem to do my sig figs. 7.5 has 2 sig figs, so I'll end with 2 sig figs, my 1 and 2. The 1 will kind of round down, so I'll end with 120 grams of CH3OH. And that would be, in theory, how much I'm supposed to make from the reaction if everything went perfectly. So 120 grams is our theoretical yield. All right, so now let's give this next example a try. We're going to follow the exact same process. First, determine the limiting reactant. Second, use the limiting reactant to determine the theoretical yield of your product. All right, so this time they tell us we have 3.4 grams of CO, and we're reacting it with 2.2 grams of H2. So now what makes this problem slightly different than the one before is that instead of starting in moles, we're starting in grams. So this means before we're ready to use the mole ratio, we need to convert from grams of each reactant to moles of that same reactant. So if you're not already in moles, that's the first step, is to go from grams to moles. We do this again by using the molar mass. So look on your periodic table and add up carbon and oxygen to get 28.01 grams per 1 mole. And then look for hydrogen, that's 1.01, multiply that by 2 to get 2.02 grams of hydrogen per 1 mole. Then we're ready to go to the mole ratio, where we compare the moles of each reactant to the moles of product. And this should look the same as the problem we just worked because we're having the same reactants, same products. So the mole ratio for methanol, its coefficient is 1. Carbon monoxide has a coefficient of 1. And hydrogen has a coefficient of 2. All right, so now let's go ahead and do a little calculator work. So I'll start with the 3.4. So 3.4 times 1 divided by 28.01 times 1 again. That gets me 0.12 moles of methanol. Then I do it for hydrogen. 2.2 divided by 2.02. And then times 1 divided by 2. That gets me 0.54 moles of methanol. All right, so now I ask my question, what is my limiting reactant? In this case, it's carbon monoxide. All right, so this is my limiting reactant, and that means hydrogen is my excess reactant. So once we determine the limiting reactant, that's the one that will determine the amount of product made. So I'll use my limiting reactant, and now just like before, I'll go from moles to grams using methanol's molar mass. And I found that earlier, 32.05 grams of methanol. Okay, and then we'll solve it one more time. 0.12 times 32.05 divided by 1 would get me 3.8 grams of methanol. And again, that's my theoretical yield. In theory, the amount of reactant I should make based on calculations from the limiting reactant. All right, this next part is kind of an extra thing for pre-AP, so we'll skip over that for now. And now we'll go and talk about percent yield. So percent yield is kind of how you tell like how well you did in the lab. Basically, how much product you actually made is compared to the theoretical yield. So our formula for percent yield is you take the actual yield, divide it by the theoretical yield, and multiply by 100. And so it's essentially representing a ratio. And what that ratio tells us is how efficient or how good your reaction was. If your percent yield is high, that means your reaction was efficient. If it's low, that means it was not very efficient, at making the product that you calculated. And so what we're going to do to save ourselves kind of on some work is we're going to use our work for the I do and the we do. So back here, the I do portion, we found that the theoretical yield in that case was 120 grams of methanol, okay? Now again, if, let's pretend that this I do had said, instead of finding theoretical yield, if it had just said, what is the percent yield? What we would have to know is that in order to get percent yield, you need to determine theoretical yield first. So you'd go through your steps for theoretical yield, find your answer, and then you would be able to use it in your calculation for percent yield. So percent yield is actual yield over theoretical yield times 100. So it says if 95 grams was actually produced in the lab, what is the percent yield? So we take our 95 actual yield over our 120 gram theoretical yield and multiply by 100. So 95 divided by 120 times 100, that gets me 79.17%. So about an 80% yield, not terrible. I've definitely seen worse than that. All right. And then now let's try it one more time for the we do. So for the we do, again, we found that our theoretical yield was 3.8 grams. All right. And then it tells us the actual yield was only 3.2. So again, the percent yield is what we actually make in the lab over what we theoretically should have made on paper times 100. So actual yield 3.2 divided by theoretical yield 3.8 times 100, and that gets us 84.21%. Okay, and so out of the two reactions, the second one was more efficient because it had a better percent yield. All right, and so again, just kind of as a heads up, on some of the practice problems for the homework, it will ask you it will give you kind of a scenario and say you have 5 grams of reactant 1 and 3 grams of reactant 2. What is the percent yield? So just remember, before you can find percent yield, you need to go through your steps to find theoretical yield. Then you should be able to continue on with percent yield. So theoretical yield comes first, then percent yield. All right, thanks for watching and good luck as you practice.